We're given the function f of x is equal to x to the fourth minus 8x, and we're asked to check to see if the mean value theorem applies to this function on the interval 0 to 2. Further, if the mean value theorem does apply to the function on the interval, we're asked to use it to find all the values of c that are guaranteed by the theorem. So let's start by seeing if the theorem applies. We only need to consider two things: continuity on the closed interval 0 to 2 and differentiability on the open interval. Well, this is a polynomial function. Polynomial functions are continuous everywhere, and everywhere includes 0 to 2. So this function is continuous on 0 to 2. Polynomial functions are also differentiable everywhere. Differentiable includes the open interval 0 to 2, so we satisfy the differentiability requirement. So we can definitely apply the mean value theorem. Now, once we can apply it, what happens with the mean value theorem? Well, what we do is we find the slope of the secant line that passes through the points on the function that are at the endpoints of the interval. So we'll have a point 0 f of 0, we'll have a point 2 f of 2, those are two different xy pairs, and we can find the slope of the straight line that goes through them. That's the slope of the secant line through those points. That's also the average rate of change of the function over that interval. That's where this mean value idea comes from. It's an average value, an average rate of change of the function over the interval. The mean value theorem, when we can apply it, says that somewhere within the interval, the function's instantaneous rate of change, that is its slope or its derivative, will be exactly that average rate of change passing through those two endpoints. So the first thing we need to do is figure out what that average rate of change is. So our slope is going to look like f of 2 minus f of 0, that's the difference in our y values, in this case divided by 2 minus 0. And f of 2 is going to be negative 16, and f of 0 is going to be 0. So we'll end up with 2 minus 0. Right, 2 times 2 times 2 times 2 is 16, minus 8 times 2. Why did I have a wrong value here. Excuse me for talking to myself for a moment. So we have 2 times 2 times 2 times 2, that's 16, minus 8 times 2, that's also 16. We should get a 0 here, so we're going to have 0 minus 0 over 2 minus 0. That's 0 over 2, or a slope of exactly 0 when we look on that interval. So that says that somewhere in the interval, the instantaneous rate of change, that is the derivative, has to be equal to that value. So let's consider f prime of x is equal to 4x to the third minus 8. And let's figure out when that is equal to 0, the same slope that we have for our secant line here. So we're going to end up with x to the third is equal to 2 if we divide everything by 4 and then get the x's by themselves on one side. And that says that x will be equal to the cube root of 2. And that's a value that will make the derivative 0. And we can see that if we plug that into the derivative, cube root of 2 cubed is 2, times 4 is 8, minus 8 gives us 0. So that's the value of c that the mean value theorem guarantees us.